Hi, my name is Hannah, your RCC virtual assistant. In this video, I will show you how to create and edit a simple script to submit as a job. Let's start by creating a new file using the VI editor. You can use any editor of your choice, but make sure it won't insert any special characters. For example, do not create any script using Notepad in Windows. It will add some unreadable characters to your file. I like the VI editor because it can be used from any terminal, including the one in On Demand. Opening the VI editor is very simple. Just type VI in the command line, followed by the name of your file, and press Enter. To start typing, press A in the keyboard. This will activate the typing mode. Now, we are ready to start creating our first job script. The first line should always be the shebang. It tells the system that this is a bash script and should be executed using the bash shell. In our case, this line is optional because bash is the default shell in our compute nodes. However, it's a good practice to include it in every script we write. Now, we are ready to create the header of our job file. It is a set of options preceded with #sbatch and located before any commands. These options tell the scheduler, also called workload manager, what resources should be reserved for our job to run. They are things like the amount of memory or number of CPUs needed, and for how long these resources should be reserved. Remember, the cluster has limited resources. Whatever you reserve will not be available to any other user. So, if you reserve more resources than needed, they will sit idle and will be wasted. If many users reserve too many resources that they don't need, the performance of the cluster will decrease and things will take longer to run. Also, the more resources that you reserve, the longer your job will sit in queue waiting for them to become available. On the other hand, if you request less resources than what you need, the job will fail. In the beginning, it will be a trial and error process. It is better to request less resources and increment the values if you get any related errors. Soon, you will figure out the amount of resources that your most used routines require. Be aware that sometimes a job can work with one dataset and fail with other if the data is larger and perhaps requires more memory. We'll go through some examples of the errors you could get related to resources and how to fix them. First, we need to specify the computational resources that the job requires. Specifically, number of nodes, number of tasks or processes, number of CPUs, and amount of memory. In most cases, unless your application mentions being multi-process or that it uses MPI, you only need one node. Reserving more than one with a non-MPI application will waste resources, because the other nodes will sit idle and won't be used by you or any other user, and it won't make your job run any faster. Since one node is the value by default, we don't need to specify it. In this node, we can run a number of tasks or processes. These are independent instances or copies of your program and have their own allocated resources, like memory to temporarily store data that is being used for calculations. Most software runs using only one process, unless it specifically says that it's a multi-process application. Requesting more tasks than what your program uses will not make it run faster and will also waste resources. We can request one task by using the following directive. The task or process that we request can run parts of our program in parallel using threads. Threads are a subset of instructions that will run in parallel on different CPUs. CPU is like the computer brain, which performs all the operations. If you know that your program creates 7 threads, you can request 7 CPUs. But if your application does not mention multi-thread, only request one. In this case, the program will run using only one thread independently of how many CPUs you reserve. It might even not run much faster than in your local computer. If you know the amount of memory that each thread is expected to use, you can specify the memory per CPU needed. If we reserve one task with 7 CPUs and 1 GB per CPU, the total memory reserved for by job will be 7 GB. Or you can just specify the total amount of memory, and the scheduler will figure out how much to give to each CPU. Sometimes it's hard to know in advance how much memory your job will need. Start requesting a small amount. And if you get an out-of-memory error, increase the value. Don't be surprised if your script works perfectly with one dataset and fails with other. It could be that your second dataset was bigger and needed more space in memory. Let's add to our script the S-batch options that you just learned. This script doesn't use parallelism. So, I will request one task, 1 CPU per task and 1 GB per CPU. Let's add now the job name directive. I like to put it on top, but the order doesn't matter. Specifying a job name is not mandatory, but very useful because it's easier to remember a name than a numeric job ID. The name you specify will appear with the job ID number when you monitor your jobs, and it can be added to the name of the log file. It's better to use a short and descriptive name rather than a very long one. We must specify the wall time. This is the maximum amount of time that the job will be allowed to run. In our cluster, the maximum value you are allowed to request is 7 days. But very few jobs take this long. The format of this directive is 2 digits for the hours, 2 digits for the minutes, and 2 for the seconds. So, if I wanted to request 1 second, I would write this. If I wanted to request 1 minute, I would write this. And if I wanted to request 1 hour, I would write this. For this example, I will request 1 minute. If you want to specify the number of days, you will add it before the hours, followed by a dash. Here you can see a few examples on how you would request a wall time of 1 day, how you would request a wall time of 2 days, and how you would request 3 days, 2 hours, 1 minute and 30 seconds. In the rare event that your job need more than 7 days, which is the maximum time allowed, write your script requesting 7 days and then submit a ticket asking for your job to be extended. You'll need to submit your ticket before your job hits the wall time, because we can only extend it while it's still running. Now, we should specify the group account. This is not your user account. Instead, this is your PI network ID. Unless you are API, then this will be your own network ID. Unless you are submitting to a partition different than normal, which is the default queue, there is no need to specify the partition, although there is no harm on doing so. But if your job requires more than 7.5 GB of memory, then you will need to submit to the Big Mem partition, and if your job uses GPU, you will use the GPU partition. This is a simple script, so we are just using the normal partition. Another directive that is optional, but can be very useful, is output. Here you can use a file pattern to name your output log file. For example, if you use the following pattern, %X will be replaced by your job name, in this case my job, and %J will be replaced with the job ID. So, if my job ID is 12345, the log file will be called myjob-12345.out. There are other symbols that you could use in the pattern. For more information, please visit the following page. There are many more directives or options that you can use. In a future, more advanced video, I will explain some of these options, but you can also visit this link to find all the available options. Now that we finished the header, we can start writing the actual code, the instructions that will be executed. In this simple script, I will only print certain information about the job, such as the date and time when it started running, the job name and ID, and the number of CPUs available for my job to use in the node where it is running. Remember that if you are using a special software, you must load the corresponding module at this point. Add the module load instructions after the header and before the commands. If you ever get an error saying command not found, it is most likely because you forgot to load the module. Well, that is all for now. I hope that you have learned a lot and found the information useful. See you in future videos.